All right, let's work another type of example of a problem. Let's say you're on a plane and you're going 500 miles per hour and you're going due south. So let's say it's here and you're going due south and this is 500 miles per hour. There is a northeast wind, so right here, a northeast wind, let's say 80 miles per hour, all right? So right here is going to be my origin. I want to know, how does this wind, 80, how is this wind affecting this plane? Like, what is the actual directional bearing of this plane? What is the actual speed of this plane? Because even though you may be cruising at 500 miles per hour, the wind is pushing against you, so it's actually going to have to slow you down a little bit. So how does this actually work? This is where our parallelogram method will kind of help us out to visualize what's actually going on. So if I have, well, if that's 500, my 80 should be way shorter, but it's okay. I'm going to draw out a parallelogram. I know my resultant, and this is really exaggerated so you can see. So this is the actual path that the plane would be flying based on an 80 mile per hour wind, a northwest 80 mile per hour wind when you're going due south 500 degrees. All right, so what we actually need to do here is we actually need to add and find the resultant vector. Well, that's interesting because I don't even have angles, but I do. If they're saying you're going exactly northwest or northeast, this is 45 degrees in standard position. If I'm going due south in standard position, that right there is, what is that, 270 degrees. So we can write these as vectors. I can say, let's say vector W for wind is going to be 80 times cosine 45 degrees sine 45 degrees. All right, went off the board a little bit, so I'll slide over. So my wind vector is going to be 80 times the square root of 2 over 2, square root of 2 over 2, which is going to give me 40 root 2, comma, 40 root 2. All right, so that is my W vector. That's my wind vector. Now, let's find the vector for my plane. So my P vector, P for plane. Let's see, 500. And I'm going to do a vector of cosine of 270 degrees and sine of 270 degrees. Well, this becomes 500 times 0 times negative 1, which gives me 0, negative 500, which just makes sense. You're going down 500. All right, so now I have my two vectors. Let's do P plus W. P plus W. So I'm going to do 40 square root 2, 40 square root 2, plus 0, negative 500. All right, voila. So this is pretty straightforward. P plus W is going to give me 40 square root 2, comma, 40 square root 2 minus 500. So that's my vector. Now I need to know the magnitude or the speed of the plane. Well, this is just my distance formula. I'm going to find the magnitude of P plus W, which is going to be the square root of 40 square root 2 squared plus 40 square root 2 minus 500 squared. When you throw this in a calculator, you're going to approximately get 447 miles per hour. All right, so the plane, even though it's going 500 miles per hour, the wind's affecting it, and it's actually slowing it down to about 447 miles per hour. Now, what is the actual heading? Because it's truly not going due south, because that wind is also pushing it off to the side. So my theta, I'm going to do arc tangent of my x component, my y component over my x component. I'm going to do 40 square root 2 minus 500 all over 40 square root 2. These do not cancel, so do not make that mistake. So I'm going to say my theta is approximately negative 82.73. I'm going to add 90 to this, which is going to give me about 7.3. So that means this right here is 7.3 degrees. So I'm going to go south. It's going south 7.3 degrees, and I'm going east. So that is the directional bearing, and this is the actual velocity of the plate. It's a fairly straightforward problem. It's a little bit more complex, but you can start seeing the power of vectors. Hi, I'm Mr. Buzzer, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.